Hi, welcome to Delmarva Tech. This video is about how to code the PWM for fading an LED. So we're going to learn a couple new concepts in this page, so it might be a little bit of a longer video, hopefully not. So when we were blinking an LED, you would either turn it on and have it have 3.3 volts go through it, or you turn it off and have 0 volts go through it. Well, since the Pico W is a digital uh, microcontroller, there isn't a way to have analog voltage. Like you can't have, well, I only want 2 volts on it instead of 3.3. But we can get around that a little bit. Um, the good thing about the Pico W is that and all microcontrollers is they're extremely fast. So um, if you want to turn the Pico on and off, you can turn it on and off thousands or even millions of times possibly uh, to get it to do things and just the way it works. So let's when you want to so if you want to get a less than mimic less than the 3.3 volts, you can do this thing where you turn it on and off really fast, usually 1,000 times a second or something like that is probably fast enough that you won't notice any blinking. If you slowed it down enough, you might notice, the blinking of it as it turns it on and off. But if you go anything over a couple hundred, but we usually use 1,000 for the blinking speed, then you can actually adjust the voltage by how much time you spend on and off. There's a chart I found online that shows, like, if you want 80% voltage in this A one, you keep uh, the pin powered 80% of the time, and then 20% of the time it's off, and that'll give you the value you see in the green there. Same way with if you wanted 20%, if you only wanted it on, you're off 80% of the time and only on 20% of the time, and you get 20%. It would appear to the LED that you're only giving it 20% of the 3.3 volts. So, maybe 6 volts, or I mean, 0.6 volts. If you turn it on and off for the same length of time, you're going to get 50%. So it would be like half brightness. Um, and then, of course, if you wanted it on 100% of the time, that or full brightness, you would just say, leave it on 100% of the time. And the same way, 0% of the time, you would say, I want it on for 0% of the time. So anyhow, that's pretty much how it's called pulse width modulation, because you're changing what they call the duty of the pulse. So you got your whole period is up here, the full length, the on and the off and the on is your period, but your duty is how much of that time it spends on. So that's how we can mimic um blinking, I mean a fading LED without having analog voltages or something. So let's get to the code and we can talk about it. So here's the code, and you might notice that we're still having to get our pin, because anytime we work with a pin, we got to have it. So from machine, we're importing pin, but here's another one. This is the PWM module that we're importing as well. And of course, we're going to sleep for a little bit each time, so we're going to need time. So in our LED project, our basic blink, here's the basic blink one up here. We set up our LED with the pin, and we called it pin out, and we called it a red LED. So when we do the PWM, we do it slightly different. We still have to declare the pin, but we do it inside the PWM object. So we're calling this our LED, and we are, since we want to do the pulse width modulation on it, we're calling a PWM module on it. And it wants to know what object you want to, what pin object you want to do. So we have the pin object 13. Now, since PWM is an output, it automatically knows you don't have to put pin dot out on this. So that's a good thing, a way of doing that. So once we have our LED object that's a PWM object, we have to set it up a little bit. So like I said it before, you have to set the frequency that it's going to do the up and down on. And I think you can go like from 10 hertz all the way up to a million hertz or megahertz. So you could do it either. I think you go up that far. I'm not sure about the ranges there, but basically, if you just leave it at 1,000, you're going to not see the blinking of it or anything like that. So when we do that, we'll ignore the for loop here for a second. When you're ready to set how bright the voltage on that pin is and how bright your LED is going to be, you do this LED. We did LED dot frequency to set the frequency. To set the brightness, we're going to say LED, and we have to have this funny thing here. It's DUTY underscore small u and then 16. And mainly what this does is to remind us that it's a 16-bit number. And if you remember, we were talking about binary numbers in the video, if you watched it right before this, that a 16-bit number can have numbers between up to 65,536. Again, we're using zero, so our numbers on this zero start, so it's 0 to 65,535 is the range of numbers that can be in here. So you could do that and um, uh, have a number, any number like that is in between here. And to get it to fade in and out like a heartbeat or whatever, we're doing a loop and we're going to do this real little sleep. This is 0.0002. So this is 2/10 of a microsecond or 200 nanoseconds, which are small numbers. But like I said, they can do these timings pretty slow and still get it right. So, I mean, or fast timings on that to get that. And so that's how we would set it. Now we'll talk about this for loop. We used a for loop in our button lesson, and we just said for X in range of 10, and we put 10 in there. So that's the very basic you can do for the range function. And what that did is actually, it's a way most computer programs work. When you do a range, you start at 0 again. So if you have a range of, and you put 10 in there for the range, it's going to go 0, 1, 2, 3, up to 9. And when it gets to 10, it's going to break out of the loop that it's doing, and it won't do this for the number 10 if you had just 10 in there in that lane. But you're still getting 0 through 9, so that's still, you're doing 10 loops with it. That's why it doesn't use the last one, because it's 0 based, so they don't want to use the last one. So range can also have what we got here. It can have a start, which we have on this one is 0. We can have a stop, which is the number that we want to increment up to, and then +1. So if we want to stop at 30,000, we put 30,001 here. And then The step is how many numbers you want to jump each time. So you could jump 5 at a time or something like that and get it to do it that way. And that's might be a good thing to follow up this lesson on, is to change this to 5. And then you'll have to make this number larger. Actually, you would want to make it, maybe if you did 5 here, you might want to do 0.001 and see if there's any difference in what you can tell. If you make your increment too large, like if you made this by 100, then you would probably see the brightnesses as they go up. But if you just do one, you can check it out and see what you think, where you can see the difference of how big a step you can go before you notice it. So that's what we're doing with the range. So the first time we go through here, it's going to be a 0, and it's going to do this. And since we say for X in range, we're going to make the duty cycle 0. And we were just talking about that using in the diagram. When you have a duty cycle of 0, the LED is going to be off. So the first time through this loop, it's going to be off. It's going to sleep for a very little time, come back up, and it's going to increment this, and it's going to go to 1, and it's going to be barely on, and then 2, 3, 4. And the reason we're doing this is we want this to get done in a reasonable amount of time. If we set this to like 1/10 of a second, we probably couldn't sit around long enough to wait for it to get bright. So this is why we have these numbers here. And you can actually figure out by multiplying the 30,000 times this 0.002 to find out how long it's going to take to go from 0 to the top of this range here. And if you multiply these two together in a calculator, you'd figure it out. And I think it's like 1.5 seconds or something like that, I think is what I calculated earlier. I may be wrong on that. But anyhow, so that's what we're doing on that. So this for loop is going to brighten the LED every time through there. But when it gets up to through 30,000, if you remember, I said that this X can go all the way up to 65,000 plus. But on a LED, you really stop seeing the increase in brightness after about halfway. It does get more voltage to it, but the LED just doesn't respond. Our eye doesn't pick up the extra brightness. So a lot of times we'll just do like halfway there, or just about. So 30,000 is a good number. And the LED will be bright enough that you can see it. You could play around with that too. You could make this 65,000. Anything below 65,535 in here would be good. So then once we get all the way bright, it drops out of this one and it goes to the next one. And this time we're going to start out with X at 30,000, which is the full brightness, our full brightness that we had when we left there. And it's going to do one loop through there then. But this time we're going to go all the way back down to near -1. So 0 is right before -1 when you're counting backwards. So it's going to go back down to 0. So we have to put a -1 in there so that it actually goes all the way off. And our step, as you can see, our step up here was 1. So it was incrementing each time by 1. Now that we have a -1 here, it's going to come down each time by 1. It's decrementing by 1. So it's going to, each time through the loop, it's going to come down. So, and then we're doing the exact same thing. So this is going to get dimmer and dimmer and dimmer each time through the loop. And eventually it's going to be 0 and it's going to break out of this loop. But since we are in a while true, it's just going to go back up to the top and start over. So it's like a heartbeat. So I actually have this running now. So I don't know if I can get close to the camera or not, but you can see that it's kind of brightening and dimming. The camera doesn't pick it up too well. I got several LEDs on here, but just have it hooked up to the blue one. Another thing is I'm going to post this code with pin 13. But if you happen to have another pin, if you got pin 16 wired up with an LED already, you don't have to change the wiring. Just go in here and change this to 16 or something. I have other LEDs. I think they're on 12. So gonna stop the code, put a 12 in there and rerun it. And you can see that the yellow LED, you really can't see it quite as well, but it's doing the same thing. It's dimming and getting brighter. And so that's what we're going to, that's what your progress of your lesson is for the day, is to copy this code and get it running and see how it is and wire up the LED that you have, and play around with these numbers and the step values and everything to get comfortable with them. Like I said, anything up to 65, 535. If you went bigger than that, you'd probably get an error down here saying that the number was too big. So you don't want to do that. It's possible you wouldn't get an error. Maybe it would auto correct it, but I don't think it would. But anyhow, like I say, if it doesn't look like it's changing, make sure that you multiply these two together and see how long it's taking to do the range. That's all I got for today. Thanks for watching. Hope you guys get something out of this. Talk to you later.